Okay, good morning students. Today we shall see one technique to solve one kinematics problem. Here look at the problem here. A ball is projected at an angle of 30 degrees to the incline. Of course the inclination of the wedge is 30 degrees and the velocity of projection is 10 meters per second. What is the time of flight? We know that we have a big formula to remember that. Sometimes students are likely to forget the formula. So we have a wonderful technique to get the time of flight. To get the time of flight for a vertically projected body, suppose the ball is projected vertically up with a velocity u. The time of flight is 2u by g. You know that. Actually, I want to tell you something. 2 times the velocity perpendicular to the plane. I am repeating again. 2 times the velocity perpendicular to the plane divided by acceleration perpendicular to the plane. In that way you write it down. It's better. That is the time of flight. Provided the ball comes back to the same plane. If it hits some other plane, that technique cannot be used. Suppose the ball is projected obliquely like this at an angle of theta. What is the velocity perpendicular to this plane? U sin theta. And what is the acceleration? G. So time of flight is 2 times the velocity perpendicular to the plane, that is 2 times u sin theta by g. All of you know this formula. So the best way to remember is 2 times the velocity perpendicular to the plane divided by acceleration perpendicular to the plane, provided the ball comes back to the same plane. Okay, right. That's the best way to remember. So now I am going to clean this part. So just keep it in mind. Now for this problem I am going to apply the same concept here. Now I can split up u into 2 parts, u cos theta, u sin theta. Now I want u sin theta, that is 10 sin 30. I am splitting this vector along the plane and perpendicular to the plane. 10 sin 30, that is 5 meters per second. 10 into sin 30. Okay, sin 30 1 by 2. So I already got the velocity perpendicular to the plane of projection. Now I require the acceleration perpendicular to plane. Of course you know g is vertically down. 30, this is 60, this will be 30. So this will be g cos 30. That is 10 root 3 by 2. So it comes to 5 root 3 meters per second square. Now you catch hold of these two fellows. Sum is over here. I got the velocity perpendicular to the plane of projection, and remember the ball comes back to the same plane of projection. Then only this technique is applied. So 2 times the velocity perpendicular to the plane divided by acceleration perpendicular to the plane. We have only one acceleration perpendicular to the plane. That is the component of g. So time of flight is 2 times the velocity perpendicular to the plane is 5 by acceleration which is perpendicular to the plane 5 root 3. Therefore t is 2 by root 3 seconds. So we got the time of flight in one immediate step, right? So what is the time of flight? 2 by root 3. Therefore the ball comes and hits back to the same plane, taking a time of 2 by root 3 seconds. Now let us see how you can find the range. I will just drop one perpendicular. Where it has hit, from there drop one perpendicular. Name this as x. I don't want to remember any formula now. Don't require to memorize any formula. Now this is your range, the distance travelled on the incline. Cos 30 is x by r. Cos 30 adjacent by hypotenuse. Therefore r is x by cos 30. Cos 30 is root 3 by 2. 2 goes up there. That is, this is the range. But what is the value of x? X is the horizontal distance covered by the projectile. So x is nothing but, now I want to split 10 into 2 parts. 1, look at my hand carefully, 10 cos 60, 10 sin 60. Previously I was splitting in this way. Look at my hand carefully. 10 cos 30, 10 sin 30. Now my splitting is like this. 10 cos 60, 10 sin 60. I don't want this fellow. I want 10 sin 60. I mean here 10 cos 60 I want. These are 10 cos 60, 10 sin 60. 10 cos 60 is 5. So 5 into time already we got 2 by root 3. That is 10 by root 3 meters. That is nothing but distance equal to speed into time. There is no acceleration in the perfect horizontal direction. This is not horizontal. This is the perfect horizontal direction. This is slope. This is not horizontal. This is horizontal direction. The velocity in the horizontal direction of a projectile remains constant. Therefore, distance equal to speed into time. Direct formula, like in the 7th standard, what you use, the same formula. No half at square there. So x equal to ut. So what is the velocity of this in the velocity of the ball in the horizontal direction? 10 cos 60, 5 into time already we got. So I got the value of x. Now I am going to substitute here 2 by root 3 into x is 10 by root 3. That is 20 by 3 meters. So it's a wonderful technique here. We got the range, we got the time of flight. Once you get the time of flight, range is very simple. Let us recapitulate once again what we have done. So what we have done here is, first we have split up 10 into 2 parts. 10 cos 30, 10 sin 30. I am not interested for 10 cos 30. 10 sin 30 is 5. And g is always vertically down. The component of g perpendicular to the plane. We got it 5 root 3. Now what is the formula? 2 times velocity perpendicular to the plane divided by the acceleration perpendicular to the plane. 2 times of 5 by 5 root 3. 2 by root 3. That's the time of flight. So with alpha, beta and all, so many formula you have that you cannot memorize it. This is the best way. This technique can be applied provided the ball comes back to the same plane and hits the same plane. Suppose the ball goes and hits somewhere else, some other plane. This technique cannot be applied. But it's a very useful technique where you need not memorize any formula. Okay, that's well and good. Now we want the range. This is the range, the distance traveled on the incline. I can find out x. X is the horizontal distance. Horizontal distance equal to speed into time. There is no acceleration in the horizontal direction for the projectile. So I can find out 10 cos 60. 10 cos 60 is 5 into time. We got the value of x. Once you get the value of x in this triangle, look at my fingertip. This is a triangle here. Cos 30 is x by r, from which we get r directly. Okay? R is 20 by 3 meters. Of course, we can calculate the velocity with which it hits and the angle at which it hits and so on. There are several other techniques which we can discuss later on. Thank you. Good luck.